Hello everyone, welcome to the final study section, how time flies. And let's just jump right in. So uh let's just go over what we have covered in this semester. We cover a lot. So 13 chapters. But when you look at it on a higher level, if you look at it from the if you have an overview of it, actually it has many repetitive things here. So basically, all the problems, all the contents actually falls into these three categories. So whether we talk about the problems about mean, problems about two means, problems about proportion, or linear regression. So these are three main types. These are three main types. And for each one of them, you get a lot of problem about hypothesis testing. What is a null hypothesis? What is the alternative hypothesis? You also get a lot of problem asking you to calculate the confidence interval. So and you also get asked about you're also given the confidence level and the significance level. So the significance level usually denoted by alpha. And the relationship between the significance level and the confidence level is the confidence level is 1 minus alpha. So that is the relationship. And another thing is test statistics and p-value. So these two guys are tied together. Basically, if you want to calculate p-value, you have to have you need to calculate test statistic first. And then for the critical value, there's another story. So critical value has nothing to do with test statistic or p-value. Critical value only have relationship with either confidence level or significance level. And I will talk about later. And another big topic is that when should we use z-test and when should we use t-test? And later we talk about linear regression and correlation coefficient. So that's the overview. So let's jump right in the proportion. So when we get a proportion problem, we need to check the condition first. But how do we know that we have a proportion problem? So when we see percentage, that means we are looking at proportion problem. Then the condition we need to check is pretty straightforward. You need to have a simple random sample. You also need to have this. It's also called success failure condition. So when you see P0 here, n times P0. So which means here it is hypothesis testing. It's using P0 because the hypothesis testing, like the null hypothesis is P equals to P0. So that's where P0 comes in. But when you are doing confidence interval, then you might need to change it to um, n times p hat or n times p sample. Yeah. Yeah, p sample or like p underscore sample. Yeah. And yeah. So after we check the condition, let's look at the hypothesis testing first. So here, P0 is the things that we want to test on. And so what is P hat? P hat is what I just tell you, like P sample. How to get P sample? P sample is equal to what? How to calculate that? So for example, we send surveys to 50 students, and then 20 of them get the third dose of COVID vaccine. And then how do you then the proportion of students that get the third dose would be 20 divided by 50. That is P sample or P hat. So here it lists out different alternative hypotheses, whether you are doing a one tail or you are doing a one tail, or you are doing two tails, and whether it's upper tails or whether it is lower tail. So that is the alternative hypothesis. And here there's something you need to look at, like how do you calculate test statistics? So here is the formula. Here is the formula to calculate test statistic. And here is the formula to calculate the confidence interval. So the Z star here is Z critical value. Oops. That is Z critical value. Z critical value. So yeah. So let's look at the one mean problem. The problem is about mean. So again, we need to check the condition first. So the data comes from a simple random sample, independence, and also the sample size is large and is greater or equals to 30. Otherwise, if the sample size is less than 30, the data should be approximately normal, like the population of the data should be approximately normal. And yeah. So how can we solve the problems like confidence interval? So here is the formula here. So T star here is T critical value. This guy is T critical value. And how do you calculate T critical value? Then is showing here. So how to calculate T critical? So QT the left area, and the degree of freedom. So that's it. So when every time you need to calculate the confidence interval of a mean, then look at this look at this formula, and then yeah, just follow it. Another thing is the hypothesis testing. So here is how you calculate the test statistics, and yeah. So when we look at the two means problems, which means we are comparing two samples to see whether the population mean has a difference. So again, it is similar to the one mean problems. You need to have simple random samples, and also two groups are independent together. Of course, the size of the sample needs to large, greater than 30, otherwise it need to be normal. And how to calculate the confidence interval? So this is a formula, and yeah. So the SE standard error, the standard error, the SE standard error is just this guy, this guy. And just be careful here, the degree of freedom, it is the minimum of M1 minus 1 and minimum of N2 minus, yeah, minimum of M1 minus 1 or N2 minus 1. So uh, so when you look at um, the one mean problem here, the degree of freedom is N minus 1. So just be careful. And also hypothesis testing of mean, how to calculate test statistic. And these are the formula how to calculate test statistic. So yeah. So again, we go over all three categories already. So as you see, there are formulas to calculate the test statistic. But how can we calculate p-value? So I just put a proportion problem example here. So the way to calculate p-value is highly depend on whether you are a one-tail test or upper tail test, whether you are upper tail test or lower tail test or two-tail test. So every time you get after you calculate the test statistic, you go back and look at your hypothesis testing, the setting. So why this is important? Because this determines how you calculate. So if this is upper tail test, you use these two formulas. If it's a z-test, then use the first one, and the other use the other one. So, and when you look at the lower tail test, then you just use this formula. Yeah. And you just p norm or pt the test statistic value here. This is the test statistic value. So what about two-tail tests? So two-tail tests, then then you need to use this one, and don't forget there's a 2 times because this is a two-tile test. And another thing is this is a negative absolute value. Negative absolute value. So just be careful here. And in the degree of freedom, you just put the suitable one, whether n minus 1 or minimum 1, n minus 2. So it depends the case you're using it. Then the other case is how to calculate critical value. So as I mentioned, critical value is only related to significance level alpha or confidence level 1 minus alpha. So if this is a left out test and this is lower tail, then you use these two. So it's pretty straightforward. Then if it's the right tail, then it's the upper tail. Then you just use this one. So it's already there. So another thing is the two tail. If it is a two tail, or if it is a confidence interval, you need to calculate. So if it's a confidence interval, you need to calculate, you always use two tail. Or if you are in a hypothesis testing, there is two tail, so you need to look at these slides. So for the confidence interval, you have Z critical, you need to calculate. You have T critical, you need to calculate. Use this one. This is the formula you want to use. And if you are in a hypothesis testing that is two tail, and you need to find the critical value, then you will have two critical value because you are a two tail test. Then I think in one of the problems you did, if you remember, so at that time you calculate an upper critical value and a lower critical value. And that's why, because it is a two tail test. But remember, if you are dealing with critical interval, confidence interval, then you always use the right-hand side formula. All right. Let's jump right into the linear regression. So linear regression, simply speaking, you're giving a bunch of data. You're giving a bunch of data, and you're trying to find a line, a straight line that approximate the data the best. So here in our class, we only consider y is equals to a plus bx. So that is the formula of this model, the formula of this linear regression line. So a plus bx, where a is called the intercept. Remember this, you will see in the output of your R code. And B is the slope. And the slope is also related to the correlation, whether there's a correlation. And so y equals a plus bx, but in our slides, you will also see y equals to what, beta 0 plus beta 1x. So it's the same thing. So it's up to you. Yeah, it's the same thing. So yeah, so let's look at this. So there are a few things I put here. So how to, for example, how to plot the data. So use this to plot the data. And when you plot the data, you can see you may be able to figure out what is the outlier. And also how to find the correlation coefficient. You do this after you loading the data set DF. And how to find the linear regression line, the model. So you use both two formula. You define an LM0 equals to this LM y tilde x theta equals to DF. And then you enter the summary LM0, and it will just give you this guy, something like this. So it may sound overwhelming. It's a lot of information here, but let me just tell you where you should look at. So this is the output of the summary LM0, and you only need to look at this right square here. This one is the intercept. You remember y equals to as plus b, a plus bx. So a is the intercept, or the beta 0 here. And x is the value here. X is the value is a. This is the b value. So basically, if you are gain this output, so in this case, the linear regression model, the formula would be y hat because it is a prediction. Y hat, the hat means it's a prediction value. So y hat equals to, so 37.8164 plus negative 1.7129 times x. And don't get confused about this order. So I mean, the questions, you may just flip it. So don't put it in the wrong way, even if you already calculated it. So which one is A, which one is intercept, which one is B, which one is this slope? Don't miss the order. And this is the intercept. And this one is the slope. And when you are doing a hypothesis testing of this linear regression model, so it will ask you for the p-value. So p-value actually is already given here. You can either look at here or look at or look at here. So this is the p-value of the slope, or p-value of the correlation, the hypothesis testing you are testing on. So yeah, so another thing here let me just clean it up first. So when you see, sometimes you need to calculate this confidence interval of the slope. Then what is the standard error SE here? Then this one is this guy. It's this one. Yeah, and T star is the T critical value. Yeah. And so don't forget that here T star or T star or T critical value, it is equal to what? Is equal to QT, the left area. DF, the degree of freedom, is equal to M minus 2. So it's not M minus 1, so be careful. But that's all the information you need. And when you do the hypothesis testing here, yeah, similar things I also mentioned. So how to calculate test statistic? Yeah, it's something very similar. So and how to calculate the confidence interval. Oh, this is repeated. But anyway, here and test statistic. Yeah. So that's it. And at the end, just some tips here. So understand the problem first, and understand the problem first. That is the most important thing here. I know you guys actually have a lot of practice, and you guys know the material, but like when you misunderstand a problem, even if you know how to do it, but you still get it wrong because you just misunderstand it. So that is the uh, first and foremost things, understand the problem correctly. Then how to understand it correctly? So uh so as I start this review section, I talk about like how all the things fall into these mainly three categories, whether it's a mean, whether it's a two mean problem or the proportion problem. So then it determines it also determines whether you are using a z-test or a t-test. So so Professor Mr. To talk about like so when we deal with problem with mean or two mean, we are just t-test, or you can most of the times a t-test, or you can just treat it as a t-test. But proportion problem, you're always a z-test. And another thing to keep in mind is if you're confused, so t-test is always used when the population standard deviation is unknown. But that's when you use the t-test. And in most of our problems of mean or two means, when the population standard deviation is not given, or it just tell you you don't know it, you don't know the population standard deviation, then absolutely t-test. But when you look at the proportion problem, then 100% is a z-test. Then another thing after you determine whether it's a mean, two means, or proportion is look at the problem, whether it's a hypothesis testing or confidence interval. So then if it is a hypothesis testing, then look at be clear what is the null hypothesis, what is the alternative, and whether it's a one tail, it's upper tail or lower tail or two tail. So that determines how you calculate the p-value, as I talked about before. And the last tip is make a formula sheet for common R commands. And it's great to follow some conventions when you do the calculations. So that's basically how you usually do the calculation. For example, what I will do for the proportion problem, I will use P0 and P samples to denote on the values, or like mean, I will use if it's a population mean, if it's a population mean, I will usually just use mu. If I use if it's a sample mean, I use X bar. Like, if you are pretty clear how you use it in the R code, it will help you have better like have clear code and better chance of get a question right. And that is just my convention, and you can just follow what you used to. So that's all the contents I want to cover today. Another thing is so go to the this page is important for you guys. So go to your modules, and then at the top, the third items code for R you need. So I just want to mention here how to import a data frame, how to import the whole table into R. So basically you can just only use method one is totally enough, and you should definitely get used to it. So there are three versions. If you are using an R in Windows that is installed in your Windows computer, then use the first one. If you use the R installed in your Mac, use the second one. If you are using the RStudio Cloud, the POSIX Cloud, then use the third command. So for the third command, you just replace this 3 dot with the data you have. So let me so I will demo these two commands, how to use it, in case someone still not familiar. So let me demo the Mac version. So I have my R installed on my Mac right now. So let me just pick a question here. So for example here, this one. So so you see the table is horizontal, it's not vertical, as we usually see. So when we see a horizontal table, we need to use a spreadsheet to help us. So we first copy all the data, including this header, attendance, and runs. So go to a spreadsheet. So here you want to paste it. So in Windows, you press Control-Shift-V. In Mac, you press Command-Shift-V. So that's how you get the data, paste it. And you see it's already selected. So you copy it again. So Control-C or Command-C to copy it again. Control-C in Windows, Command-C in Mac, or you can, right click and copy. And then important thing, pick another cell and then go to edit, go to paste special and transpose, and you just get all the data as transpose here. And since it's better to keep our code clean and nice, so we just replace it to X and Y so that the R will not complain about it. So after you replace it, so you can select this data and then copy it again. Then this data is ready to copy and to R is ready. But before that, if you want to paste it to the R in your Mac, so you need to first copy this code. So first step, copy the code, paste it in R, press enter, run it. It will show you a warning message, but ignore it first. Ignore it for the first time. Then go back to your data, copy it, and then go back to R. So you press the upper arrow in your keyboard to get the previous command, and then press enter again. Then no warning message. And then you press DF and enter to see whether the data is loaded correctly. So DF enter, you see here X, Y, the value. It looks, yeah, all the value is loaded correctly in R. So that's good. And this is how you load the data or table into R. So first step, you copy the code into your R, run it the first time, you will see a warning message that's common. And then you go back to your data, copy your data, and then go back to, and then after that, go back to your R, use the up arrow to get the previous command and press enter. And then you enter DF to check whether you have loaded the data into R correctly. Yeah, that is how you get the data into your Mac version of R. It's the same in Windows, but you need to use a different command. So what about the POSIX Cloud, the RStudio Cloud? So oh, I should have opened this. Wait a second. So if you are using RStudio Cloud, then you need to use the code here. So the first step, copy the code, paste it in the RStudio Cloud, then press enter. Well, since I already have copies, but yeah, you would be actually, yeah, let me demo this again. So when you copy and paste oh yeah, so basically the first step, let me repeat again. So copy the code, paste it here. Copy the code, paste it here. And you see the 3 dot here, right? So for the 3 dot, you delete the 3 dot, go to your data, choose your data, copy it, and then paste it here. directly paste it here. Paste. After that, press enter. And then you enter df, press enter to check whether the data loaded correctly. So you see here, I loaded in the R in Mac and I loaded in the RStudio Cloud. So they are loaded correctly. So that is how you enter your data to your RStudio Cloud. So basically, is this command. Replace the 3 dot with the data that you copy and then run it. Yeah, that is how you get that. And hope that helps you solve the problems like this. Yeah, another thing I want to mention here, just quickly mention. So when you do the hypothesis testing for this linear regression problem, so it's a hypothesis testing for the correlation. The correlation here, it is as you remember, like the linear regression model is y equals to a plus bx. B is the slope, and the correlation is the slope here. And but in the problem, it usually use rho. Use rho to denote that. So just rho, yeah. Then that is the slope, and there's also the b in the a plus bx, or the beta 0 or beta 0. Oh no, beta 1. So that's another thing, small details, and I think that's it for today's videos, and hope you guys have do well in the final or the projects. So I will going to hold a study session on Thursday, and during that time, most of the time I will just use for Q&A. So bring your questions and or the question about your projects, and I hope this video helps, and yeah, thank you everyone.